Hi everyone. Welcome to the first CHAOS event. We are certainly looking forward to summer on Lake Superior. I don't know about you, but I am very excited, especially after this long winter and it seems to be an even longer spring. And I'm so excited that you were able to join us today. So my name is Melanie Perello, and I'm a Coastal Management Fellow working in Minnesota's Lake Superior Coastal Program. And I'm currently serving as a coordinator for this group, CHAOS. So this meeting, we're going to start with a short introduction about what CHAOS is, get a little bit of an idea of who's in the room today, and then we have guest speakers from the U.S. Army Corps of Engineers and the National Weather Service. We're going to talk to us about Lake Superior water levels and lakeshore flooding. And as Natalie hinted at, we're going to have some dedicated time to discuss these presentations and how they impact us in our own lives, and using breakout sessions that we'll be able to use here in Zoom. So first, I wanted to explain what is CHAOS. CHAOS is the Coastal Hazards of Superior Community of Practice. Now, when we think about CHAOS, we often go to the negative view. We see the impacts and damages of these hazards and how they hurt our communities and perhaps even hurt ourselves directly. But I also want to point out that CHAOS can be a positive. It's just an overwhelming amount of information. We have so many people and agencies working on these issues, producing valuable data and resources, developing new projects and implementing solutions. And that's where this group comes in. As a community of practice, CHAOS serves as a platform for sharing and learning about coastal hazards. We aim to do this through events like this, monthly newsletters, and collaborative projects. Now, one of the things that we're focusing on is about communicating about coastal hazards, making sure that people are aware of what's going on is currently in the, both in Minnesota and Wisconsin's coastal areas, but also throughout the Great Lakes and on the salty coast. We want to serve as a platform for sharing about your experiences and lessons you've learned, and help to support some collaborative projects and identify data and resources for everyone. So who can join CHAOS? CHAOS members is anyone who has an interest in coastal hazards. It's free and open for anyone to join. We currently have about 70 members representing federal agencies, state and tribal groups and agencies, and most importantly, our coastal communities, such as local governments, stakeholders, business owners, non-governmental organizations, and researchers. Currently, we have a higher representation from Wisconsin, and is coming from the Minnesota side, we obviously need to step it up, but we also have several people joining us from Michigan today. Now, one of the things that we're asking our new members is to take a quick survey to tell us what they would like the community to focus on. So I'm going to highlight a couple things that we've learned through that survey. The first is, what coastal hazards were of the greatest interest for Minnesota and Wisconsin? And no surprise, the topics that we're going to be talking about today came up as the top ringers. Lakeshore flooding, shoreline erosion, infrastructure vulnerability, and lake level fluctuation. We're going to hit on some of those issues today. We also asked what you would like to see from CHAOS. And our top responses were about information on ongoing projects and the lessons that other communities have learned and how they might be able to be applied to our own communities. We'll definitely be working on these, both in today's event, but also in our future communications and in future events. So I hope this gives you a quick background on what CHAOS is about. And if you're not already a member, I hope you'll consider joining. And we'll be sure to send you the link to take the survey and how to join after this event. So now it's time to see who was in the room today. During registration, we asked everyone for two extra things. One was your zip code, and the other was about your favorite activity on Lake Superior. So I'm going to show quickly the results of that. So as you can see from the zip codes, we have great representation, particularly from Minnesota and Wisconsin's coast on Lake Superior, but we also have some representation from the Twin Cities, other parts of Wisconsin, particularly in summer Wisconsin and Green Bay area, Upper Peninsula, and other parts of Michigan. Now, we also asked what your favorite activity was on Lake Superior, particularly thinking about what you're going to want to do this summer, hopefully in a socially distant way. And the top response was hiking. That other option was our second most popular response. So if you're one of those other people, Please let us know what that means to you. We also saw a lot of people who want to do paddling, fishing, boating, birding, and only one person who was interested in surfing. Apparently we're a lot more sane in this room than some of the people I see around us. So we're going to, Natalie's going to pull up a quick poll. We have 2 questions to try to gauge why you're here today and what your role is. So if you can take a quick second and respond to these. They're multiple choice, so feel free to choose multiple answers. You should be able to see that right on your screen. We'll give you a minute to do that. All right, as we see some of the results coming in, let's see, where are we seeing big responses? So why are you here today? Discover more about chaos. It's a very popular response. Identify how lake levels will impact my community. Understanding those summer lake level projections. Let's see what else. Learning how I can improve lakeshore flooding modeling. Needing human interaction after a month in isolation. I thought that would be much more popular. I know I definitely would vote for that. Let's see, what is your role in relation to lake shores and flooding? Let's see. I see a lot of people who are planning for the impacts and response, education and outreach, community management and planning, impacted stakeholder, managing those natural resources, and involved in research. Well, thank you, everyone. This helps us understand if we'll have a question at the end, so we'll see if we actually answered any of those questions, and hopefully you'll come out of here with meeting those objectives. Now, as we all know, as we're moving into summer, that we can expect to see more activity on the lake and along the coast. Recent high water levels and related storm impacts have been a significant concern for many of our communities. We are very excited that we have 2 guest speakers today who are going to talk to us about lake levels and impacts. So I'm going to stop sharing my screen so that our guest speaker can join us. It's a pleasure to introduce Deanna Apps. She's a physical scientist working in the U.S. Army Corps of Engineers Detroit District. She's coming to us from the Detroit area. She's going to talk to us today about what we can expect from Lake Superior this summer. So Deanna, are you ready?
I am now unmuted. I am ready to go.
All right, thank you.
Great. Thank you, Melanie, and it's a pleasure to talk to this group today. So I'm going to kind of go over hydrology, some of the things that have occurred over the last year or so, and then I'll talk about at the Corps we produce a 6-month water level forecast, and I'll talk about what that forecast looks like for Lake Superior. So to get started, I just, I always like to show the high water impacts across the entire region. So these are just some photos, top left there from, Lake Superior this fall. Top right is a picture from South Haven, Michigan, the Lake Michigan shoreline. The bottom left is a picture from the Lake Erie shoreline in Stony Point, Michigan, and the bottom right from Oswego, New York on the Lake Ontario shoreline, just to reiterate that this really is a Great Lakes wide event of high water that we've experienced, over the last year or so in the basin. So just to, I know this slide is a little bit of text, but I just want to go over some notes about Great Lakes water levels, so we're all on the same page here. So when we measure water levels, we measure them as an elevation above sea level. and that's based on the International Great Lakes datum of 1985. I'll reference Michigan Huron as one lake. We consider them one lake since they're connected at the Straits of Mackinac and they rise and fall together. So from a forecasting purpose, we acknowledge them as one lake. At the core, on our webpage, you can get lake-wide daily average water levels. And then at the end of the month, we average those daily levels to compute lake-wide monthly means. And that's really the main data set that we report out on. We use a network of gauges to calculate those daily lake-wide mean levels. And, really that's just done so when we give a lake-wide daily mean, it's really a reflection based on still water, and we're not seeing that variability at one specific location. So each lake uses, a number of gauges. I think on Lake Superior, I think there's about 5 or 6 gauges we use to calculate that lake-wide daily mean. At the Detroit District, Corps of Engineers, we are technically what we say the keeper of official monthly water level statistics, as well as Environment and Climate Change Canada. We coordinate our data with them. Currently, our monthly mean water level period of record stretches from 1918 through 2019. Currently, 2020 data is considered provisional. And as you'll hear me talk about through this presentation, that the primary drivers of water level fluctuations are changing weather patterns and that resulting fluctuation in water supply. So this is just another kind of overview slide as well. I always just like to reiterate, how large the basin is. That graphic there on the right that you're seeing, everything highlighted in green is in reference to the Great Lakes Basin. It's large, covering over 14,000 miles of shoreline. Of course, both on the U.S. and Canada, as it is an international border, so it covers 8 states and 2 provinces. On the left diagram, that's really showing you a side profile view. I like showing this because it's a reminder of how water is flowing through the system. So, if water is beginning in Lake Superior, it flows through the St. Mary's River into Lakes Michigan and Lake Huron, through the St. Clair River into Lake St. Clair, through the Detroit River into Lake Erie, through the Niagara River over the Niagara Falls into Lake Ontario, and then, of course, out through the St. Lawrence River to the Atlantic Ocean. I do like to note on this slide that there are 2 places in the system where outflows are regulated. One being through the St. Mary's River from Lake Superior into Lakes Michigan and Huron, and out of Lake Ontario through the St. Lawrence River. Regulation of these outflows is a responsibility of those respective boards of control. So the International Lake Superior Board of Control and the International Lake Ontario St. Lawrence River Board of Control, and that is under the authority of the International Joint Commission. I want to stress that the regulation of these outflows cannot prevent extreme high or low water levels, nor can it fully control water levels, due to the main factor that water levels are mainly driven by weather and Mother Nature. So now I'm going to talk about kind of what are the factors that impact water levels. So you'll see highlighted in red there is a term which we call net basin supply. And that includes the precipitation over the lake, runoff to the lake, minus evaporation. So those 3 variables are our main component of the water supply. However, we also have to account for inflow from the upstream lake and outflows out of that lake as well. So water levels, especially monthly mean water levels, really go through a seasonal cycle on the lake. So every year we go through a seasonal cycle, and a lot of that has to do with the hydrologic cycle. So typically in the late winter, usually that's when we experience our seasonal low, and a lot of that has to do with snow is accumulating. Typically the ground is frozen, and that's typically a time when we're reaching the seasonal low. As we get into the spring months, like especially in April and May, water levels are rising, and that's due to snow melt, increased typically rainfall during this time, which also leads to increased runoff, especially over these last couple years when you already have saturated soils. Usually in the summer, as we get into July, August, and September, that's typically when we're reaching that seasonal peak. And during this time, we're seeing increased sunshine warming the lake waters. And that's important as we get into the fall and early winter, because that's when we're typically experiencing the seasonal decline in water levels. And that's really attributed to cold air now moving over these relatively warm lake surface waters. And that's really what induces evaporation and contributes to the seasonal decline in water levels. So this is our full period of record of water levels. As I mentioned earlier, that goes back to 1918. That blue line is the monthly mean water levels. The red line is your long-term average annual level, and you can see we have a hydrograph for each lake. So Lake Superior is at the top, Lake Michigan, Huron, St. Clair, Erie, and Ontario are below that. And what you can really see from looking at these is you can denote periods of highs and low water periods on the Great Lakes. Most recently, we can see the recent decade plus of fairly low water, which had record lows that occurred on Lake Superior and Lake Michigan Huron. But then once 2013, came, we started to see a transition. And over the next couple years, we saw really a record-setting rise on the lakes. And annually, we've been steadily rising since then. And that's what's culminated in those record high water levels that we've seen so far in 2019 and in 2020. So this slide is going over some of those monthly mean water level records that we've seen. In 2019, we started to see monthly mean records being set in May of 2019 on Lake Superior, St. Clair, and Erie. On those three lakes, water level records continued through September. You can also see that Ontario joined the party in June and July and setting records in those respective months. You'll see an asterisk next to Erie and Ontario in June and Lake St. Clair in July. So those are noted because they are now the highest monthly mean on record for all months in our period of record. So not only did they break that, June record, that's now the highest monthly mean on record for all months in the case of Erie and Ontario. October through December, we didn't set any monthly mean records, and although we were very close, but then that, as we entered 2020, that changed, and then we started to see records again on Lake Superior in January and February of 2020. Now Michigan Huron has also been setting records in 2020 for the first 3 months, and Lake St. Clair and Erie have also set records so far in this year. And we'll have April data pretty soon, and we'll have to see if we're adding any more to the list. So the next question is, well, why are levels so high? How did we get here? And really, it's attributed to a very persistent wet pattern we've seen over the Great Lakes Basin over the last several years. So what you're looking at here, this is Great Lakes Basin precipitation, of course, all on the U.S. side of the basin. And there's over 120 plus years of data. And these are the ranks. So it's looking at the last 12 to 60 months periods in the Great Lakes, and they've all been the wettest on record. So you can see this top one here, the April 2019 to March 2020. That's the wettest 12-month period on record. And if you continue to go down this list, you'll notice that it's been the wettest 18, the wettest 24, wettest 36, 48, and 60-month period in the period of record. So over several years, we've continued to see this wet pattern, and that's really what's transitioned water levels from basically a period of low water to now a period of high water. So now I'm gonna move in and just talk about the 6-month forecast. We do these forecasts at the beginning of every month. So this forecast is from the beginning of April. We'll be doing one here shortly at the end of the week for the beginning of May. But I'll first go over kind of how you read these graphics. You can access this on our webpage. I put the link there on the bottom. But these are based, you can understand the level by understanding that this is zero line, is each lake is based off a chart datum. So for Lake Superior, the chart datum, or that zero line, is referenced at 601.1 feet or 183.2 meters. Your feet axis here is on the left. Your meter axis is here on the right. If you're looking at it from a feet perspective, so your reference level's at 0, that's 601.1 feet, then each of these lines above that is +2 inches until you get to +1 feet, +2 feet. This blue dash line is the long-term average monthly mean water level. The red line is the monthly mean water levels that have occurred over the last 2 years. So this is beginning April 2018 through March 2020. What I've highlighted here in yellow, these are the water level records that were set last year on Lake Superior. So from May through September of 2019, those were the record highs that you've seen in the respective water level. So far in January and February, we've set provisional records. The March record was the March level was just slightly below the record that was set in March of 1986. However, the March 2020 level was the same level as it was in March 2019. So from a March monthly mean level perspective, we are where we were at last year at this time. However, you do see that beginning in April, Lake Superior is forecast to begin its seasonal rise. And we are forecasting for that for Lake Superior to peak in August at the record high level that was set in last August of 2019. So we are expecting near record high water levels. And that's denoted by this green dash line, which we consider our most probable. If we see wetter conditions, wetter than normal conditions, then we could be potentially up on the upper part of this red band. That red band represents a 90% confidence range of water levels. So, and of course, if we're drier than normal, we would be toward the bottom part of that band. But that green dash line is what is the main or what we call most probable. That's what I'm saying when I say we're forecasting to peak in August at the record. I'm referring to that level based off that green line. I also just put in Lake Michigan Huron in here as well. I know this is a Lake Superior focus group, but just to kind of reiterate that we are expecting on Lake Michigan Huron, really we've seen records the first 3 months so far, January, February, March. And, on Lake Michigan Huron, we're forecasting above record highs really for the full forecast period. And actually, Lake Michigan Huron didn't experience much of a seasonal decline this year. And the March level was actually 14 inches above the level of last March. So things are tracking much higher this year on Lake Michigan Huron. The last thing that I wanted to touch on briefly was a tool that we have called the Water Level Outlook tool in our office. I'll focus here more specifically on Lake Superior. What this tool allows us to do is it allows us to answer questions like, what if, given certain conditions? What if this occurs? What would water levels be like? And as I mentioned earlier, that net basin supply variable, that's your precipitation plus runoff minus evaporation. We have net basin supply data that goes back to 1900. So what this tool allows us to do is saying, given all those historical water supply sequences, what would water levels look like if we, routed all those supplies through our regulation and routing model? So that's what this tool is doing, and that's really what's represented by this gray range. So this is a very similar graphical setup, where these black dots are the long-term average monthly mean water levels. This black line is what's historically happened over the last 2 years. You can see those records again from last year through March of 2020. And then you'll see that gray range. And that gray range is representing that range of water levels that could occur based on historical water supply. You can see if we have very wet conditions, we would be surpassing records quite a bit. But if we are drier than normal, we could potentially see water levels back near average, maybe in the 6-7 month window. This goes out 1 year, so it's a 12-month outlook. This orange shaded area and line, that's a 6-month forecast. That's what we just went over on the previous 2 slides. And then currently we every 3 months we update the scenarios. The scenarios were just updated in April. And currently, we are comparing 2 years that also had low ice cover, similar to this past winter, and kind of the differences between the water supply conditions that occurred following a winter with low ice cover. So that's also available on our webpage as well. Here's just a link of water level resources that are available on our webpage. You could get to a lot of these probably just by Googling Detroit District Great Lakes water levels, and you could get to a lot of these links by doing that. And lastly, I just also want to make a note that we also have a Great Lakes high water webpage that we've created specifically for this event. And you can access, a lot of other resources here. I know a popular one is this Living on the Coast booklet. People tend to ask for that one a lot, and that has to do with, really how to protect your shoreline in certain situations. And there's also frequently asked questions and contact information. My contact information is right there, Deanna Apps. That's my phone number, and it is forwarded to direct line to me. And as well as my email and my supervisor's contact information as well. So that's all I have. I'll stop there, and I will stop sharing my screen to pass to the next.
Thank you, Deanna. Does anyone have any questions for Dee? If you do, be sure to use that chat box right down at the bottom. See, I'm not seeing any questions come in, but I do want to point out that Adam Beckley has been sharing links as she was going through a presentation for the water level forecasts and for the Great Lakes information and Great Lakes high water pages from the U.S. Army Corps of Engineers. You can find those links if you click on your chat box. Okay, well, thank you so much, Dee.
Yeah, no problem.
All right, so our next speaker is joining us via phone. Give me one moment, I'm going to share my screen. I've got his slides up. Oops. All right, Joe, we're ready for you.
All right, can you hear me?
Yes.
Awesome. All right, so welcome. My name is Joe Moore, and I am the Warning Coordination Meteorologist for the National Weather Service in Duluth. You can go on to the next slide. The National Weather Service in Duluth is one of 122 local forecast offices that cover the United States. Generally, what we do is we issue routine forecasts, watches, and warnings. Our office covers Northeast Minnesota, Northwest Wisconsin, and parts of Western Lake Superior. We're highlighted in yellow on that map there. Our office is a 24/7 office, and we support a diverse range of customers, from land managers and government officials, the aviation sector, marine, the public. Generally, what we do is we try to issue products and forecasts and give people the information they need to make decisions related to the weather, whether that's an individual making a decision of whether they should go out for a hike if there's going to be a storm, or an emergency manager that's making a decision to close down a road and during a blizzard or something like that. So on the next slide, I have talking about how we predict weather on the lake. So we have kind of three primary tools that we use. One is observations. That's reports we get into our office, buoy data, weather stations around the lake, that sort of thing. We have models, computer models that use the current information and try to push it forward to help us predict the lake levels and the waves and the weather. And then the third thing is the humans, the people that work at the National Weather Service that actually take all the information in, using our experience, our education, the latest research, and actually make the forecast. So the next slide, on slide 4, I kind of talk about the challenges that we have in lakeshore flood prediction. And there's kind of three big challenges we have. One is the limited experience we have. 2 is the limited reports that we've had both in recent storms and through the past. And 3rd is just limited number of tools that we have to monitor and make the forecast. So in slide 5, I talk about limited experience. As I think a lot of those people on this call are probably very well aware, for the last 20 years, lakeshore flooding was not really something that we had on Western Lake Superior because of the historically low lake water levels that had existed for, like I said, for much of the past 20 years, up until about 2006, 2007, or 2016, 2017. And according to our records, from what I have been able to find in our records, that we didn't have really any lakeshore flood or damage events that impacted Western Lake Superior between 01 and 2017. And if you're shaking your head, or if you're like, yeah, there were some storms, I'm going to talk about that on the next slide. So slide 6, another challenge we've had is just limited reports. And when I say reports, I mean reports that have gotten into our weather office or that our employees have gone out and found. But looking back at our historical records, we only have a handful of storms that have been documented with monetary damages or in the case of other storm events, injuries or deaths. I don't believe on Lake Superior we've had any lakeshore floods that have had any injuries or deaths directly attributed to the storms. But looking back, we've only had a handful of these reports. And even during storms that we know that there's been some kind of flooding and damage, these official reports just haven't gotten into our system. And so what this is called storm data. This is essentially part of what the National Weather Service does, which is document all major storm events, whether it's large hail that falls, whether it's a blizzard. One of the tests the National Weather Service does is archive all of this information. Now, I'm actually kind of new to this position, and this is kind of one of the things that I do as the warning coordination meteorologist is make sure all storm events are properly documented. I've only been doing this for a few months, and so there's been other people in the past that have been responsible for this, and for whatever reason, some events I just don't think have been cataloged as well as they should have been. Another challenge that we have, though, even when we have limited reports, even if we had great reports, another challenge we have on slide 7 is the limited tools. So when we forecast the weather, we have a ton of tools. We have rules of thumb. We have a ton of different weather models that are constantly being worked on and refined and developed by organizations and individuals all across the world. We don't have that when it comes to the storm-driven lakeshore flooding events that have caused a lot of the damage along the shoreline. And when I'm saying like storm-driven events, I'm talking about damage that happens in the course of a day or two from one event. That's kind of what the National Weather Service is worried about, is kind of those events that happen that tomorrow, you're going to have damage on the lakeshore. That long-term erosion is another challenge, but that's kind of not exactly in our wheelhouse with the National Weather Service. We're more focused on the big storm events that cause really crazy winds on the lake, big waves that cause direct damage and cause impacts to personal property and infrastructure. And so most of the prior work that there is, the tools and research that there has been done for flooding is coastal flooding, which is done on the ocean, which is a whole nother thing because you deal with tides, and obviously it affects a much larger area, much more denser populations on our coasts. And so there's more research and models on the coasts, the East Coast and the West Coast of the United States and other coasts, but we don't have a lot of research on these much smaller scale Great Lakes storms. So on the next slide, we've had a lot of recent storms in the past few years, and we've been looking primarily at the water level observation station in Duluth. There are other stations around the lake, but we've been using the Duluth one mainly because all of the storms that we've had, besides a few that have impacted Graham Ray, almost all of them, we've had most of our storm reports are coming into Duluth. We're at the head of the lake. The natural geography of the land tends to point all of the winds at Duluth at the head of the lake, and it tends to squeeze the wind as it goes. I'm sure everybody in this call has seen a map of Western Lake Superior. When we get those really strong east-northeast winds, it tends to be funneled and really increase as we get into the head of the lake. So Duluth has been a great spot to look for this damage. Anecdotally, we've kind of looked at the water level data as the storms happen, and looking at the I think it's 5 or 6 minute data that comes into to the water level gauge, and trying to assess like at what level are we getting really big waves and flooding, and how does that correlate? So this is kind of a number of storms that we've had in the past, and you'll note that there is 2001 event, which there is a newspaper headline that we have saved in our office when we had really big damaging a really big damaging storm that caused incredible damage to the lake walk. It happened at levels that we're kind of routinely seeing even without storms now at 602.6 feet. And so we've done some research to try to figure out at what level does a storm event cause damage. So the next slide, slide 9, we've started to do some initial research. That map on the right there, that arrow is pointing to basically where that water level station is. So that's inside the harbor, not on the other side. So it's not directly facing the lake on the inside of the harbor, but anecdotally, we've kind of been using 604 feet as the level that's going to produce damage. But at lower levels, obviously, we've had some events that has produced damage. So it's been a challenge, and we are actively doing some research. One of our forecasters has been kind of assigned tasked to look back at these storm events, look at the meteorology, look at the wave data, and see what we can determine. On the next slide, I have kind of some of the tools that we're using right now to warn for lakeshore flooding. And so these products on the left are kind of our legacy tools. The Lakeshore Flood Watch, Warning, and Advisory are tools that all Great Lakes offices have to warn for damage and flooding on the lakeshore. We have a watch, that means significant impacts are going to happen in the next 12 to 48 hours. A warning means our confidence is higher and that there's going to be a serious threat to life and property from lakeshore flooding, usually within the next 12 to 24 hours. And then we have the advisory, which is minor lakeshore flooding. Up until 2017, our office had never issued these products. We did not really even know we knew how to issue them because we used the same software, but we really didn't know at what levels do we issue one of them. Only until we were seeing incredible damage being done to the Duluth Lake Walk, where we're like, oh, hey, we should probably be issuing one of those lakeshore flood warnings. Let's use one of those. That'll get the word out. But it's been a challenge ever since that storm of when do we issue the warning, what's the difference between a warning and an advisory, which is a problem we have with a challenge that other offices have had as well on the Great Lakes, as all of the Great Lakes levels have risen up. Other tools that we have, though, are on the right, kind of the emerging technology tools, as we like to call it. So putting information out on social media about the impacts as they're happening, making the graphics that you may have seen in other presentations in the past, and we put those on our social media as well and on our website. And then we also will directly email a lot of our partners. Our partners at the federal, state, tribal, and local levels get direct emails from us with these weather reports. We call them situation reports. But we will also kind of directly email our partners when we think that something like lakeshore flooding and other weather hazards are going to happen. So those are kind of the tools we have. On the next slide, slide 11. So one of the reasons I wanted to speak to this, and one of the things that I've kind of hammered at similar presentations in the past, is that what we need right now in order to better predict these lakeshore flood events, these damaging lakeshore flood storms, are reports. The more reports that we get, the more kind of data points that we can get of what event caused what damage is going to help us produce a prediction of that damage in the future. And it might help us mitigate it as well. The lake levels will probably go down at some point, and then they'll probably come up again at some point. And so these reports are not only useful for the next year or 2 or 3 when we have these high lake levels, but they're also going to be useful 15, 20, 30 years from now when lake levels come back up and we have another round of historically higher lake levels. So these aren't just for kind of the weather prediction and research right now, but they'll be used for generations to come. I think Melanie or someone has probably shared a link we have a very, very rough lakeshore flood page that we've created, but I've got a form on there. You can also report lakeshore flooding and lakeshore damage from specific storms to us using any of those methods on the slide. We have a general office email, nws.duluth@noaa.gov. We want reports both in real time and for past storms. But if you have damage from a previous storm, if you have photos, videos from a storm, if you have any cost estimates, those are huge because we can document that and say, listen, there was $400,000 worth of damage to this property, or that sort of thing. So that data is really important for us to capture so that we can predict it in the future. So that 10 years down the line, we can say, listen, the dock at this location could have damage, that sort of thing. During events, again, we're a 24/7 office. So if you have damage from a lakeshore or flood event that's ongoing, let's say next fall we have a big lakeshore flood event and you're getting damage, please feel free to give us a call, an email. We're on Facebook and Twitter as well. If you don't remember our phone number, that's fine too. It's on our website as well. But we really appreciate those flood reports. And again, real-time and reports from past events are really useful to us and will hopefully help us predict these events better going into the future. And with that, I think that's about all I have. So you can go to the next slide. One of the tools we have for monitoring is obviously webcams. And so one of the things we do in our office is we capture, hopefully that animated GIF is playing. But one of the tools we have are cameras that are placed around the lake. And so we actually capture a lot of these for kind of looping. We'll loop the past few hours of various webcams around the area, and we use that for weather and water monitoring. So that's what you're seeing there on the screen. So with that, I will stop talking and allow you to ask any questions you might have.
Well, I see the only question that's come in so far is, do reports include requests for images, which you just clarified? So that's perfect.
Yeah, definitely. Yeah, capturing those images are really nice because we can, with your permission, if you have some damage that happened, we can use that damage in our imagery on social media. So we find that people will take action a lot more when they see an image of, hey, this is something that might happen with the next storm, versus a bunch of text, a wall of text that says, hey, there might be some docks that get taken underwater, or there might be other damage along the lake.
Okay, and I'm just pulling up the Lakeshore flooding report. Everybody can see it. So this is the web page on the National Weather Service page. And then if you go down, you'll see this report form. You click on that, click continue, and that's where you can make your reports. I have a question that came in. Who can report? Are you looking for officials, or are you looking for anyone who discovers damage?
Anyone that discovers damage. And so let's say you stumble across some damage, but it's actually damage that occurred and it's county property or city property or that sort of thing. We want the report, and if we need to go to the landowner or something to figure out what damage, to figure out the details or cost estimates, we can do that. But yeah, anybody can report.
And I have another question that came in. Is the National Weather Service actively reaching out to property owners to get these reports?
You know, we are not, mainly because we don't know exactly where they are, where the damage is occurring. And it's been really a challenge for us too to differentiate between the kind of long-term erosion effects from the specific storm effects. So no, we haven't really done a great job at reaching out to individual property owners in the past.
Okay, well, that sounds like that's something we can definitely work on.
Yeah.
I also have a question. Is there a 6-month precipitation forecast?
Oh, so we have, the best thing would probably be the CPC outlook. So we don't, at the National Weather Service, we're really focused on the day-to-day weather out to like the next 7 to 10 days at the longest. The Climate Prediction Center, the CPC, which is part of NOAA, they do produce outlooks of precipitation on a monthly basis out for the next few months, out to a year. But those generally are probably not going to be satisfying. They just basically say whether it'll be above or below normal precipitation levels, and often those are not correct. Predicting the long-term precipitation trends is extremely difficult. So we tend to stay focused on the next week.
Oh, we have one more question. I'm sorry, I missed it. How did you determine levels or phases of storm events? So I think that's looking at that severity.
Oh, how do we determine, yeah, like what's a warning and what's an advisory?
I think so.
We're making it up at this point.
Okay.
Yeah, it's been a real challenge for us because we don't have a clear definition from like what we call our directives, kind of our instructions of what we're supposed to be issuing. It's been very subjective. And so we don't have any hard and fast thresholds. I know in other Great Lakes offices, what they've been using is essentially they'll use like the wind. They'll say like, all right, if we're only expecting winds of 40 miles an hour or wave heights of less than 10 feet, then it'll be an advisory. And then if it's above that, it's a warning. We really haven't had enough data to collect and enough events that we really get strict. It's usually just forecaster preference, forecaster determination of whoever's working that day and what they decide to go with. But yeah, it's a challenge for us, and we don't like it because when we're predicting snow, we have very hard and fast thresholds that we use, and predicting snow or predicting rainfall amounts is a lot easier than predicting this sort of phenomenon.
Okay, well, thank you so much, Joe. This seemed to have a lot of interest, but we're running short on time, so we're going to go ahead and move into our breakout groups. So now I'm going to turn it over to Natalie, and I'll bring up the instructions for that.
Okay, sure. So as we move into our breakout groups, I'm going to